Now, as we move into the last section of Chapter 5, Section 8, remember our next class, we're scheduled for a test just on Chapter 5. You'll want to review your notes, and of course the Flip Classroom videos give you the background to do this. This is the practice. So let's start. It says the perimeter of a rectangle is 40 yards. So let's make a little picture here. And we're doing the outside edge, which is the perimeter. What are the dimensions of the rectangle with maximum area? So background would be P equals 2 lengths plus 2 widths that we had in our last lesson, and we know the perimeter is going to be 40. So I'll erase this and put a 40 there. Now, we also know we can divide everything by 2. So this is going to be 20 equals length plus width. If we divide everything by 2 here, and we want to solve for one of the letters, so we can solve for W, or we can solve for L, makes no difference, and this would become 20 minus L equals W. Now again, we're looking for maximum area, so we're going to need the formula area equals length times width. Well, this is our width, and there's our length. We can change that to x if you'd like, and it would be x times 20 minus x, to keep it in harmony with what we've been doing. Okay, so we're going to multiply, and we get 20x minus a negative x squared. So putting this in quadratic form, we have a negative x squared plus 20x. Now we're looking for maximum. Now because our a value is a -1, we know this is going to be a parabola that rises upward and opens downward. And we're looking for the vertex, which is the maximum. So our formula for vertex, and it's good to write these again to get the practice, is a -b over 2a. Now, let's see if you can figure out what the vertex would be as we pause. All right, so -b would be a -20. Our a is 1, so -1 times 2 is a -2. And when we simplify this, this is 10. So we know then that our length is going to be 10. Well, what do we have left here? So 20 minus 10, then this is going to be 10. So even though they initially described it as a rectangle, this is actually going to be a square. And 10 times 10 would be the dimensions of our rectangle, which is a square. And that would give us, they're not asking what the area would be, but we see that this checks out for our perimeter is 40. Okay, let's go on to number 2. Now again, take a moment to read the problem. Here we have a little platform that is 11 feet high. we're going to throw something or a stone up into the air. It's going to eventually reach the ground, which is 0. And we're going to throw it with the initial velocity of this. So what's our equation? Well, they're saying it's negative 16 t squared, right from the formula. Our initial velocity is 130 times t, and our initial height is 11 feet from the ground. So we're wondering, when will it reach its maximum height, and when is a time? So we want to solve this for its vertex. So vertex, and again, write this again, it's good practice, is a negative b over 2a. Now our b value here is 130, so a negative 130. And our a value is a negative 16 times 2 is a negative 32. And they want you to round this to 2 decimal places. So if you have your calculator, it's going to end up being positive. And we get 4.06. Now these are seconds that we have found the maximum. When will it reach the maximum? Well, it would be the x value of the vertex. Now, I didn't write this out to be too long, but I also want you to find the height. So what would the height be? Now, we had said in our flipped classroom video, you could put a y here. And we're solving, in a sense, if we have an x value of this, what would our y value be? Well, we put the 4.06 for the t squared, 4.06 for the t, and then plus 11, and you solve this. So take a moment to solve this, and let's see what you get. And you have to round to 2 decimal places also. 275 feet and 0.6. So at this many seconds, it will have risen to this many feet. We found it by substituting into the formula, solving for the maximum, and finding that time, and then to get the y value, putting this time into this formula and solving it. And you'll be getting some like this in your Certify. Now, for number 3, it says a store owner estimates that by charging X dollars for a certain lamp, he can sell this many lamps. At what price will the yield maximum revenue? So here it's pretty straightforward. X times 35 minus X, multiply through 35x minus X squared. Put this in standard form, a negative X squared plus 35x. You want to find the maximum. Well, we use the vertex formula, negative b over 2a. Substitute, our b is 35, so that would be a negative 35. Our a is a negative 1, So this is a negative 2. And this comes out as what? $17.50. So again, if you know how to do it, this is the model of what you're going to be doing. Now, number 4 is a challenge, so we'll spend enough time on that so you feel comfortable with what we're doing. Now, we gave lots of background for this in our flipped classroom video. Here's our equation in standard form. We want to find the vertex. Now, since A is negative, the vertex is going to be a maximum. So again, V equals negative B over 2A, which is going to equal a negative B is going to be a negative 8, and our A is a negative 1. So 2 times negative 1 is negative 2. So our X value in the ordered pair of the vertex is going to be 4. Now, keep in mind that our X value, when we find the vertex, is the axis of symmetry. So we'll put in there a negative, I should say X is a 4. Forget about the negative, no negative there. Okay, but now we want to find what the Y value is. Well, if we know that X in this formula is 4, how do we find what Y is? Well, we just substitute. So this is going to be a negative 4 that we're going to square plus 8 times X, which is 4, minus 13. Okay, so squaring, and we had done this a lot earlier in our class. 4 squared is 16, but this becomes, because of the negative outside, is a negative 16. 4 times 8 is 32, and then minus 13. Well, when we add these, we get a negative 29, and a positive 32 leaves us with a 3. So our Y value here is 3, and that is our vertex. Now, they ask us to find the zeros. Well, here we're looking for ordered pairs where X is going to be 0. And how do we find? When Y is 0, what would be our X values? Well, we have to use the quadratic formula for that. And we had said that if you are solving using the quadratic formula, it's a little easier if your A term is positive. So I'm going to multiply everything by a negative 1 and change these signs. Now you could leave it this way, but it's just easier to do it when our A value is positive. We know it's going to open upward already. But now we want to solve to find the zeros. So we're going to make A a 1, change signs, B a negative 8, and C a 13. That is, just change all the signs. Now we're going to do the quadratic formula. X equals a negative B makes this a positive 8. And I see my pen froze for a moment here. All right. Plus or minus the square root of 8 squared is 64 minus 4 times 1, which is now a positive 1, times C, which is a positive 13 now. and that's all going to be over 2a, which is 2. So as we do this, and I'll just do it here, this is going to be 64. Now 4 times 13 is 52. So under the radical, this leaves us with a square root of 12. Now, digging into our toolbox, we're going to get x equals 8 plus or minus. Now, the square root of 12 was the square root of 4, which is 2, the square root of 3. Okay, and that's all over 2. Now, we notice we can factor out a 2 from this, and it looks like this. 2 times 4 plus or minus the square root of 3 all over 2. So now our 2's cancel out. So one of our x-coordinates here is going to be 4 minus the square root of 3, comma 0. And here 4 plus the square root of 3, comma 0. All right. So this was challenging, but again, using a lot of stuff we've had. Now, they also want us to graph this. So what we're going to do is make a little t-chart, and they ask us to plot 2 other points that we haven't done so far. Well, we know our vertex, so we're going to put that in there, 4, 3. Now, we have our y-intercepts, or I should say our x-intercepts here, but let's look for our y-intercept where x is 0. What would y be? Well, if we go to our equation and x is 0, this is 0, this is 0, this will be a negative 13. And then that's a new point. So let's get one other point here. Let's say if x is 1, and we'll do it up here. So negative 1 squared plus 8 times 1 minus 13. So x squared, or 1 squared is 1, but this is a minus 1. 8 times 1 is 8, minus 13. So this is a minus 14, and a positive 8 gives us a negative 6. So here are 2 new points. So now we're asked to graph this. Well, I'm going to make a little graph here. So you can make a little graph like this somewhere. And we're going to plot these points. Now, remember, you're going to have a graph that looks like this. They're going to have a point there, a point there, and a point there. You're going to take this point at the base and put it at the maximum. And this was our maximum right here. So x was 4. 1, 2, 3, 4. We're going to go up 3. So you take it from there, click on it, drag it, and then it will make it look like that. But now you're going to take it, one of these points, this one here, and plot 1, negative 6. So there's 1, and then negative 6 is there. And then the graph comes down like so. And I'm not doing this very well here. And then it's going to have the y-intercept at 0, 13. So then it continues down, and it will go there. Now that may be off your scale. Actually, you only need to do this one because of the axis of symmetry here. X equals 4. This side forms. and continues down, and the graph is made. Okay, a lot of stuff going on here. And again, you realize you are in preparation for college mathematics. Number 5 is actually a repeat of number 3. So look at the model of number 3 and see if you can do this one all on your own. We want to know the maximum revenue price. So it'll be x times 290 minus 3x, which becomes, I'll write it in the standard form, a negative 3x squared plus 290x. And we want to find the maximum. So our vertex is negative b over 2a. b is 290, so a negative 290. Over a negative 3 times 2 is a negative 6, which is going to give us, and they want us to round to 2 decimal places, and it's a 3 repeating decimal, so $48.33. Is that what you got? Again, if you're not sure about something, ask. Remember, when our a value is negative, you have a parabola that opens downward, and its vertex is the maximum. All right, just one more. Now, for our last one, again, you have to read the example carefully. Contractor wants to build a brick wall 6 feet high. Actually, we don't need that measurement, but they're telling us what it looks like. To enclose a rectangular garden. But only 3 sides of the garden need to be enclosed because the 4th side is the building itself. So let's make a picture of the 3 sides here. And I can do it this way. This is the way we showed it with a river in another example. So what we want to find is what will the dimensions of this be if you have a perimeter so far of 168 feet. He wants to get the greatest maximum area in here. So we eventually have to find the maximum, but we have to have an equation to start with. So we know, let's say that this wall is going to be x, and this wall is going to be x. That's the dimensions of the width in a sense. Well, what would be the dimensions of this length? Well, it's going to be 168 minus the 2 x's we have on the side. Now, to find area, we only need to do area equals length times width. So we need just one of these times this. So that's what we're going to do. We're going to say x times 168 minus 2x. And then I'm going to put it in standard form. So we get a negative 2x squared plus 168 would be our area. But we want to find the maximum. So again, our a term here is negative. So we're going to solve for the vertex. The vertex is a negative b over 2a. Now, b is, there's an x there, B is 168. So this is a negative 168 over A is negative 2, so this is a negative 4, which then gives us 42. So we know X then is 42. Well, we have a 42 here, a 42 there. That gives us 84, which is this that we subtract from that, and this becomes 84. Ooh. So again, not too hard if you know what it is and what you're looking for, and keeping in mind that this 6-foot-high wall, that wasn't used here at all unless they wanted the volume, which they're not asking for here. So what are the dimensions? The dimensions would be 42 feet by 84 feet. And this completes our practice. Okay, I believe we're ready for a open notes quiz now on these lessons. And be sure to ask any questions that you might have.